Hello, Programming 2 students, and welcome to a interesting version of Programming 2. I'm currently at home, slightly sick. Under normal circumstances, I would be teaching this in person, but because of current COVID rules, I figured it was best if I stayed home if I displayed any symptoms whatsoever. So instead, we get to have ASMR programming with Mr. Carnes. Um, So let's dive right into it, because if you guys finish watching this video before class is over, then excellent. That'll be as far as we need to get. We'll open up by saying that for the substitute who is showing this video, if you see Rick's trying to play games, please smack him for me. Just kidding. You can't actually be violent to students. Um, but Rick, stay off the games, and please actually watch the video, because it would be highly rude to have to ask the um, substitute to backtrack for you. However, I will ensure that you are able to watch this video, or that you're able to get some of this code in future. Um, but I'll rely on the substitute to tell me whether or not you were trying to pay attention and whether or not you deserve to have any of the code at all. With all of that said, let's go ahead and pick up where we left off last class. Last class we finished, we didn't quite finish the maze constructor here. Um, we're missing one little step at the end where we tell the maze to basically build itself. But we did get it to where, excuse me, we did get it to where the maze um, adds walls to all of its edges. And so that's a pretty good place to start. We also made it possible for the maze to retrieve a tile at a specific location. Now you'll notice my code looks a little bit different than what you've seen previously. And that this is actually just the code that I created that I worked off of. So there's this special kind of comment you can create where you can actually describe constructors and methods, so that when they get called, you can hover over them and see these comments. So this is like Java documentation. It makes it a lot easier to use your code. So we'll probably be doing more of this in the future and having you explain your method so that you know what's going on. Just so you can see what that looks like. If I'm in my Maze Runner class and I try to create an instance of Maze, which this is complaining about the fact that it was static, so ignore that for a second. But if I hover over Maze here, you can see that everything that I had listed in that comment in the actual Maze class itself is here in this box, which is handy, as well as this parameter thing, which explains what the parameters are for. So that's pretty great. Although, actually, now that I think about it, I don't have a parameter for what the parent is, so I'm going to go ahead and add one really quick. I was trying to autofill for me. And let's just say that the graphics, or yeah, the graphics program, this is parented to. That'll work for now. It's not perfect, but it does the trick. And so now if I go over here, I can actually hover over my description, and you'll see that my down at the bottom of the params list, we have parent as well. Now, I'm not requiring you to write this. I'm just explaining this there. In fact, I'm going to go ahead and minimize it so that it's not in the way of everything. And I'm actually going to go ahead and minimize our maze constructor. And then we're going to jump down into this empty space I've got. So I have get tile, and then I've got my make vertical and make horizontal. I've minimized everything. I think, well, I might as well just take out that space, and we'll just work beneath the make horizontal wall thing here. I'm going to go ahead and move my project out of the way and zoom on in so that we can work close up and make sure you can see everything. All right, let's get to it. So the next thing that we need to take care of is actually going to be um, the recursive call for dividing our maze up. And if you remember, whew, I'm tired. If you remember, the maze is to be randomly generated. So we need to make a method that will recursively call itself and create this maze as we go. So we'll call that a private void and divide maze. Now we're never going to need to recreate the maze in the maze runner class. And for that reason, this is private. this will be called at the end of the constructor. As a matter of fact, after I go ahead and create this, I'm going to go ahead and expand the constructor really quick. And at the very end of my constructor, I'm going to go ahead and just call divide maze. Now we're going to have to come in and pass some parameters in a minute after we add them here. So we'll just leave this open for now. Now, as we divide the maze, we are going to be working by passing in a row to start at, as well as a column to start at. I've got R0 and C0 here, as well as R1 and C1. Technically, we could name those anything we want, but we'll go ahead and leave that. And then, of course, we're going to have an error up here because it's looking for parameters that we are not giving it. And we'll worry about that in a minute. Let's actually crack into the divide maze code. So, as we divide the maze, remember this is going to be using recursion. So the simplest possible thing when we divide the maze that could happen is that the maze is completely divided and that there are no longer any tiles to create walls between. So row 0 and column 0, this will tell us where one tile, basically we have 2 tile coordinates here. And what we're going to do is see if these 2 tiles are equal to each other, or like if we're looking at the same tile, then we want to just go ahead and stop our recursion. So a way we would write that is just if R0 is equal to R1 and C0 is equal to C1. So if both of these things are the same, if both rows and both columns are the same, we are in fact looking at the same tile. So we'll just stop our chop job of the maze. But if not, that's where we have to actually do some recursion. So just to be clear and to review some vocabulary, this right here is the base case of our recursion. And it is the point at which our recursion will stop. Now, because there's going to be a significant number of general cases, I'm going to minimize this. Not the whole method, mind you, just the if statement itself, so that I have maximum cleanliness in my code here. So first off, we need to grab a hold of a random tile, basically. So we're going to do int row equals, and now this is just some stuff to not worry about. Math.max R0, and then we're going to randomly generate. So random generator dot get instance dot next int. And you'll notice I didn't do an import for that, even though it does require one, because I'm just letting it go ahead and automatically import that. But up here at the very top, if something goes wrong with auto importing, we need to go ahead and import acm.util.randomGenerator. There is a Java utilities random generator, but we're going to use the ACM one here just because we want to keep everything using the ACM package and not have any interconnection there, just in case that becomes a problem. All right, now zipping on back down to line 79 for me, but for you guys it could be something else. Anyway, where we left off. So we'll get next int, and the next int we want to get is going to be R0 and R1. Now, let's be super clear about exactly what is going on here. And I'll put it even in a comment for you guys because I don't want there to be confusion. So obviously this method, and actually let's go ahead and you guys can practice doing a parameter or a method explanation parameter thingy. So you guys know that you can make a comment with a double slash. You know that you can make a comment section where just everything in between it with a slash star and then ending with a slash star. But to make one of those parameter things, you go slash star star and then hit enter. And you'll notice that IntelliJ is really clever. It's already slapped all these parameters in here for me, and then it left me on the description line. So this method constructs the maze by recursively dividing an area into 4. Oh, well, I'm going to have to drop that. Dividing an area into 4 quadrants. on each division, the vertical and horizontal wall. Ah, dang it. I keep typing too much here. The vertical and horizontal wall defining the quadrants are drawn. And an arbitrary opening is made in each of the quadrants. Then the method, Then the method calls itself on each of the quadrants. The method will terminate when the width and height of the area to divide are equal to 0. So that describes in a complex way what this entire method does. And we're not going to worry about defining these parameters, at least not yet. And I'm going to go ahead and minimize this. But what you'll notice is, again, when we do this Java documentation thing here, which I know we haven't done before, but this is a really handy way to do comments. So when I do this, if I go back to where I'm calling divide maze and I hover over it, you'll see that that entire description pops up in this box. Now, not every library you ever use will do this, but pretty much every library you ever use, should do this. All right, so now I'm going to jump back to where I was. So this is the whole quadrant thing, and we're going to do an int call, and these are just some local variables to help us keep track of where we are. So C0 and random generator dot get instance and dot next int, but this time we want to pass in C0 and C1. So we're getting random chunks in between whatever these happen to be. And now our general cases. So there's several of these. And you don't have to understand these necessarily. You're only going to worry about the general cases when we do the recursion for recursively solving the maze itself. But if C1 minus C0 is greater than or equal to 0, I'm going to try to do this slowly enough that you don't get lost. Be careful of your brackets and stuff. Mistakes in here will result in complete failure to work. Then we're going to make a horizontal wall between row C0, C1, and tile dot south. After we do that, if row becomes less than total number of rows minus 1, in other words, if we're at the end, then we need to make a random opening. If the row we're looking at, I should probably write a comment in here really quick. If the row we are looking at is not the final row, make a random, well, I'm going to write opening on the same line, even though it's going to go over. So if the row we're looking at is not the final row, make a random opening. And by opening, I mean like delete one of the walls. Not the final edge walls we had before, but I think you understand. So we haven't made this method yet, but we're going to make a method called make random horizontal opening. And it's going to take in a few parameters where we're going to tell it exactly where to make that opening. But let's go ahead and, and we have to do this twice because we have to tell we're going to have to do this twice because we have to tell both tiles that share that wall that they have an opening in them. So there's that. So if I click on one of these and push Alt-Enter and then hit Enter, it'll go ahead and make that method for me. And it should be private, so that's good. And then let's look at making a random horizontal opening. Now it's a horizontal opening because right now we're only looking at a row. And so rows are horizontal. There will be also a method for making a random vertical opening. Now the method for making a random horizontal opening requires you to tell it what row, what column to start on, what column to end on, and a direction. Now I'll pause here for a second, or maybe zoom out, because you'll notice this is a pretty long method signature here, and you don't want to forget any of these parameters. So we have a row that this opening is going to get made on, and on that row we need to know where this hole starts, where this hole ends, and whether it's basically the direction. But there's only two options for the direction in this case. There's either north or south, because when it comes to the horizontal walls, there is only north and south, right? Now the vertical walls, of course, can only be east-west. So when we make the random vertical opening, that's going to be a very similar method, but it will be handling different directions. Now the actual code in here is pretty simple. We're going to write a for loop where we get the tile. So let's say we wanted to make an opening like so. Remember this method up here, so our dividing maze, it divides the maze into smaller and smaller quadrants. So with this divide maze method, we'd basically be activating every wall in the entire maze. But that's not what we want to do. We want to take our maze, and as we divide it, we want to choose random holes to make. And so the way we do that is that we don't need a for loop. We actually just need a simple check. We just say if, I misread my notes, if the end column is greater than or equal to the starting column, then we need to fetch the tile at row random generator. I can't type. Dot get instance dot next int start column end column -1, by the way, because of the array setup. And then we do dot set wall and whatever direction got passed in and false. Now this is a lot, so I'm going to scroll out just a bit here. So this is a long method call. So take a minute to type this out, and I'll scroll up just in case you missed some of the other stuff as well. There we go. So here's divide maze. There's making a random horizontal opening. So basically, as we're dividing the maze up into quadrants, we are randomly picking places to put holes in the maze. And right now, we're only making holes in the top and bottom of our maze. And as a matter of fact, the way that we're actually going to do this is southern tiles only. So for the random horizontal opening, we're going to back up here and divide maze. I'll go ahead and zoom in actually. So let's zoom in here. We're going to pass in row for the starting thing. So we want to start at the beginning. I'm going to pass C0, call, and tile dot south. And then down here, we're passing in row, call, C1, tile dot south. Again, if this doesn't make entirely sense to you, that's okay. Okay. Now, be careful to jump to the correct spot on this if statement. So we're actually going to jump down, and we have another if block. So if R1 minus R0 is greater than or equal to 0, then make a vertical wall at call R0, R1, and tile.east. Now, before we made a horizontal wall, so again, dividing into quadrants, like the general case, this aren't even really the general cases. Let me rephrase this. Divide maze into quadrants using vertical and horizontal walls. So whenever we make, basically we're making these walls vertical and horizontal, which is dividing it into quadrants. And so we're making the wall, and you'll notice that, I have to scroll back up. So when you make a, let's use vertical for an example, you have to tell it a column that you want to make the wall at where it starts. You have to tell it where its starting row is, and then you have to tell it where its ending row is. You have to tell it where you want to make that wall, like which edge, as we went over last class, but in case you forgot. So we're dividing the quadrants up by passing in, initially we're basically passing in the entire maze and then telling it to divide it into quadrants. Then every time this function calls itself, it's going to pass in smaller and smaller quadrants until we get to the point where the quadrants can't be divided any smaller, until we're basically just looking at one tile. Now, as we use these functions to divide the maze into quadrants, we are poking holes in the walls. These basically poke the holes in the wall, but it only pokes holes if we're not currently looking at the final row. Okay. Now, that's where and remember, it's a random hole, so that's where this comes into play. So we're fetching a tile at whatever row we're looking at. Now, it can't be completely random because we need to have a general row when we're poking this hole, but then we pick a random tile out of that chunk that we're looking at, and we turn its wall off. That's what making a random horizontal opening is doing for us. Now we're basically going to need to repeat that process for our vertical walls. And I'm sorry for calling these the general cases earlier, because they're not. This is like actually separate logic, and it wouldn't actually be a bad idea for me to make another method. And to be really clear about this, I'm actually going to go ahead and do that. I'm going to make another method. It's going to be private void. We'll call it make quadrants. And let's see. Is that going to be a problem? I just thought of this as I was working on making quadrant, like separating this logic, because this logic here is not recursive. None of this stuff is. I'm just wondering if I'm going to have to pass in. Yeah, I'm going to have to pass all of this into this in order to successfully make the quadrants. But you know what? Honestly, that's okay. So for this, I'm going to grab these variables out of, or these parameters out of divide maze. I'm going to copy them. I'm going to come back down to make quadrants and paste them. Then I'm going to grab everything I've done in divide maze except for the base case. I'm going to cut it. I'm going to paste it into make quadrants. So, sorry I made a bit of a mess. Let's see what this looks like at the moment. So I'm zooming way out here. Hopefully you'll still be able to see. But we've got our divide maze, which now only has the base case in it. And then what we're going to do is we're going to call make quadrants. And we're going to just pass R0, C0, R1, C1 into it. And so every time this method gets called, it's going to make these quadrants. Now, making the quadrants is good to keep separated just by nature of trying to keep our recursive logic as isolated as possible. It'll make it easier to understand. So down here in make quadrants, what we're doing is we're picking a row and a column to make our horizontal and vertical walls in order to divide this maze up further into quadrants. And then we are making the wall, and then we're poking random holes in the wall. Hopefully that makes sense. If it doesn't, try to keep your questions handy so that you can ask them when we're next in class. But just understand that that's the basic idea. Cut the maze into quadrants. So from the initial maze, you get 4, then cut those quadrants into quadrants, and so on until you're done. As you're cutting the quadrants, you're putting walls along the edges of the quadrants, and then you are poking random holes into those walls, and that's how we're making this maze, or this random maze. So let's go ahead and get back to this make quadrants idea, actually. And let me actually go over to my version here and add this, because, like I said, I actually just decided that this would be a good idea. So please give me just a moment, and I do apologize for that. There we go. Oh wait, I'm not going to be able to make quadrants, am I? Not that way. Not with the divider like that. Shoot. Well, that's upsetting. Now that I think about it, it's going to create more of a mess to actually do this make quadrants thing. So let's ignore all that. I'm going to press Control Z. I'm a little upset. There's probably a better way to do this, and I'll have to think about that more for future. I'm going to go ahead and put this here. I'm going to go ahead and delete make quadrants and apologize to you guys profusely for any potential confusion, because I just remembered that we're going to need those int row and int call pieces here. We're going to need these in order to actually make our recursive calls. So unfortunately, we need to keep this in here. Now, of course, we could just create these and then pass them to make quadrants, but then we're dealing with a lot of extra stuff that it's almost not even easier. So what I'm going to end up doing is I'm going to make a region inside here and close all this in between that region, but we'll get to that in a minute. Sorry for the confusion. Let me check how long this has actually been going on for. Can't extend past class. We've been recording for 27 minutes. Okay, that's fine. Okay, so hopefully no one has fallen horribly behind in your code. That's what I was saying, to pay good attention. So let's go back to this second block. So this first if, this is the dividing maze into vertical or into quadrants using vertical and horizontal walls. So this if block right here is make a horizontal wall and poke holes in it. And this one here is going to be to make a vertical wall and poke holes in it. Okay. Okay. Whew. Now, after we make the vertical wall, we have to poke holes in it, which is going to be another if. So the if is just to see if we are at the edge of the maze, in which case we don't want to poke a hole in the actual edge of the maze. So we say if call is less than calls minus 1. That'll let us know if we're within the edge of the maze or not. And then we're going to make a make random vertical opening. And for that, we'll go ahead and pass in the column to start at, the row, or R0 rather, the row to start at, and tile dot east. And we can go ahead and actually copy and paste this. And for the second time we call it, we're doing row here. And here we're passing R1. Okay, and then I'm going to go ahead and click on this and push Alt-Enter, and then hit Enter one more time. And you'll see that, once again, it has made this entire method for me, just like with the horizontal opening, thus saving me from having to type all of that. That's, once again, from the red method, because it doesn't exist. You click on it, you're going to push Alt-Enter, and then once again press enter and it will make it for you. Very handy feature. Now, down in our make random vertical opening, it's very similar to the horizontal opening. If the end row is greater than or equal to, did I call it something else? Make random. Ah, I see. You just copied this over. That's why. Okay, so we actually need to change some names here. So this should be start row. And this is for the parameters, by the way. And this will be end row and int direction. So there's a problem with having it automatically make the method there, is that it just takes these names and throws them down, which is not what we wanted. So if the end row is greater than or equal to the starting row, so as long as we didn't pass in a place we don't want to make a hole or shouldn't be able to, then we're going to go ahead and fetch the tile. And this time, unlike, we need to randomly generate something first here, because we need to randomly generate a row and not a column in order to make a vertical wall. So random generator.getInstance.nextInt, and we're going to pass into that start row and then end row -1. And then we're going to do dot set wall, and we're going to pass direction and false, just like we did before. Let me zoom out again here. And apparently I typed something a little bit wrong, so let me double check. Oh, I forgot to put in this end row -1. Okay, so at this part here, this should be comma call. There we go. So right here at the end of the next int method call, we have to add call there, like that. So this is what you should have. Let me zoom in a little bit and drag over and give you a minute to write that. Oh, and I should have said this at the very beginning, but basically if you need to have the substitute pause the video, thank you very much, substitute, for being so understanding as these kids try to work through this. You're awesome. Okay, next step. And now we've minimized this. I'm going to get rid of that little extra space. And back in the divide maze method, I'm going to go ahead and give myself some space. And I'm going to do a, oh, let's see if I can remember how to do this. It's / region, I think. Make quadrants. And then come down to here and do / end region. Did that work? I can never remember because I'm so used to doing it in no, it just wanted to do that. Nope. Is it just lowercase r region? Yes. Okay, so lowercase r region is the problem. Now I'm going to go ahead and actually copy that above that. That makes a little more sense. So now the reason I did that, and you don't have to do this, but the reason I did that, so I put this region above these if statements, which if I don't minimize them are actually rather large. So I'm going to minimize those, and then this region make quadrants, I can minimize that. And now look at that. All of that code poofed away. Now these are the general cases. If, and these are basically just going to say, like, if I'm not done dividing the maze, then I need to keep dividing the maze. And I'm just going to be passing in where to keep dividing from. Problem is that we have a lot of checks to handle as we go through here. So be quite careful of your ifs. It's very easy to miss a bracket. So we have one if statement with this condition, and then we have two totally separate if statements inside of it. They're not connected by an else or anything. And then we have one other general case where if R1 minus row is greater than 1, and then we are again putting in two if statements inside of that. So these are our two general cases. And now we need to actually get this recursion going. So this first, and feel free to, once again, ask the substitute to pause if you need time to copy this, as long as you make sure that your brackets are in the correct place. So like each of these ifs is going to end up with creating 6 total extra brackets. As a matter of fact, I might even want to go ahead and make this a region unto its own and say region general cases, and then come down to the bottom of it and do / end region. And now I'll be able to get my general cases minimized. But again, that's optional. But that's a / region general cases, and then going down to the end of our general cases and putting / end region. That's just a little organizational deal. Look how neat that makes our method. Okay, so back inside the general cases, first general case, first if statement inside of it. If call minus C0 is greater than 1, then we're going to divide the maze a certain way. R0, C0, row call. And if our C1 minus call, is greater than 1, then we're going to divide the maze again a different way. Not bad. And then down here, we're going to go ahead and minimize this if right there. And then now in this other one, we have if C1 minus call is greater than 1, then we are going to be dividing the maze, and we're going to pass in row call R1 C1. And if call minus C0 is greater than 1, then we will also divide the maze again, row C0 R1 call. Actually, let me go ahead and expand this. So here would be a great place to pause. Ensure that you have no mistakes whatsoever in these if blocks, because these are essential to getting your maze to draw correctly. So pause here if you need to. Now that you're unpaused, we go ahead and minimize these if statements and then collapse that region. So now we have make quadrants and general cases of their own separate region. And as a matter of fact, let's go ahead and close divide the maze. The last thing we have to do is actually pass in the correct information for dividing the maze. So let's go up to our constructor now. That was a lot, right? Let's go up to our constructor. And we are going to divide the maze, and we are going to pass in 0, 0 as the starting points, and rows -1 and calls -1 as the endpoints. Now that makes sense, right? Because so 0, 0 would be the top left tile, and rows -1, calls -1 is the bottom right tile. And so we're telling the divide maze function to divide the maze between these two tile, or between the top left and bottom right tiles, respectively. I probably could have named these parameters better, but I'm not sure what the best name would be. If I think of something better, I'll have us rename them. But in the meantime, this isn't horrible. Okay, so now we can actually minimize our constructor. It is, well, pretty much done. And then let's go ahead and go test this. So if we got everything working right, we should be able to jump into Maze Runner. Now, it won't let us create this without... we'll just go ahead and say Maze Runner. We won't even bother to make it a init method. We'll just say Maze Runner ex equals new Maze Runner. And then we're going to say ex equals, ex dot actually, no, we're gonna have to do ex.start to get this to work correctly, and we are gonna have to go ahead and make that a init method. Now, I think if I remember correctly, you guys actually might have already done this, but if you didn't, there you have it. Classic setup for us, right? And then we're just going to say maze equals new maze, and I think the starting setup I did was like 22 by 35, but it's not really that important. And we pass this as our parent because the instance that we're currently talking about is the one that will be the parent. And then we're going to add maze at 1, 1. Actually, that's not where I added it, is it? I added it at like 10 something. If I remember correctly. Yeah, 10, 10, not 1, 1. 1, 1 probably would have worked for this purpose. We're just currently testing to see if our maze is working correctly. So if everything's working at this point, if you followed along correctly and you hit play and then run maze-runner.main, give it a second to queue up. There we go, our recursively divided maze. Now with this here in front of me, I can explain things a little bit better. So I'm going to open up the maze thing, and this way I'll be able to, darn it, I'll be explaining to you a little bit about how this, what I meant by quadrants. So like on Friday last week, we made these top and bottom and east and west walls, right? So in between these walls, I'm basically just cutting the entire maze into 4 pieces. And so to do that in the divide maze thing, it's going to keep closing it every time. That's irritating. So first off, in here I've got my base case, which says that if R0 equals R1 and C0 equals C1, and you might be a little confusing, wait, I thought R0 and C0 was the top left tile, which is this right here, and that R1, C1 is the bottom right tile, and that's this right here. Well, because this is a recursive function, when we first call it from the constructor, that's true. R0 and C0 is the top left, and R1, C1 is the bottom right. But as we divide this into quadrants, each quadrant is getting this divide maze thing called on it. And so because each quadrant is having that called on it, we have to give it a different top left and bottom right tile. So like, you know, for the top left corner of the left, or for the top left corner of the top left quadrant, yeah, it's the same tile. But, you know, the bottom right tile is like, what, this one right here maybe? Or maybe this one? Right around in this area somewhere. And so then if I actually take out the part where we we do the vertical opening thing. So actually let me go ahead and open up the make quadrants thing so you'll actually be able to see. So if I don't do this, but I'll just show you. If I comment these little pieces out about making the vertical openings and then rerun my program, the maze is just going to be completely covered in lines for the most part. Now, I'm not sure why these didn't get all of their lines. I might have missed something there. It didn't make all the vertical walls. But generally speaking, you can see how it did kind of cover everything. It looks like some of the lines kind of just failed to draw properly. That's a little weird. But anyway, you get the idea where it just divides those up perfectly. Now, if I make these openings in here again, then I've actually got a maze. And so let me go ahead and minimize that again. So as I was explaining, I have to run this. Okay. I hate it when this type of maze gets generated where it just randomly selects the same thing. But so after it divides it into one quadrant, we get to the general cases. We're basically looking to see like, okay, if my current, like if the road that I'm looking at is like, if I haven't gone off the map, basically, then I'm going to want to keep dividing the maze. And so I actually call divide maze, and I actually call it twice. So I'm actually, for each quadrant, I'm dividing that quadrant into 2 other quadrants. So you can see that like I make 4 quadrants in the first pass with all 4 divide mazes, and then each of those gets divided into 4 and so on. So it's actually doing a lot of stuff to create this maze here in the background. Hopefully you understand the general idea, even if you're not really clear on the code itself. But from here, there's only a couple little things left we have to do inside of the maze method itself before we're able to move on to the real good stuff of actually solving this maze. And you know what? Actually, I was thinking about doing those in the previous class. How much time has gone by here? Been recording for 45 minutes. Okay, so I'm gonna go ahead and just say really quick. We got to make these a getter and a setter for rows and columns, and that's where we'll stop. So we have a public, and it has to return an int because that's how we get the rows. So public int get rows, and of course that's going to return rows. Then we have to have a public int get calls, and of course that will be returning calls, just like that. We'll be using that later, but for now, we just needed to make those two, and then I minimize them. So our entire maze class looks like this. Now, at some point, it imported java.util.random. If it did, go ahead and delete that. The only imports we need are these. I don't even know if we actually need the gcontainer one. Why is that imported? We might delete that later. But there you have it. This is the maze class in all of its glory. Don't think I forgot any steps in there. I think we've got it all. So next time we'll be jumping over to our maze runner, which is going to recursively solve the randomly generated maze in here. Thank you guys for paying attention, and if there is free time left in class at this point, please feel free to, play games or use your phone or whatever it is. If you're really confused about something and you're desperately panicked, then I will be available for emails most of tomorrow. I'm going to try to anyway. But I will, of course, be taking questions when I get back. I am really hoping to be back in class on Wednesday, or in your case, Thursday. Thanks again. Have a good day, guys.